You need to make a garden which has an area less than 18 square meters. The length should be 3 meters longer than the width. What are the possible dimensions of the box? Why don't we try a rough sketch here? So we have the width x, and the length is x plus 3. 3 meters longer than the width. And we know that the area formula is base times height for a box, which is x times x plus 3. And this being the area, we want the area to be less than 18, given over here. We see that we have a quadratic inequality statement. Why don't we expand this out? We have x squared plus 3x. Throwing this positive 18 over, we have minus 18 is less than 0. So we factor this quadratic. We have x times x is x squared. And let's try 6 and minus 3. They multiply to be negative 18, but they add to be positive 3. So when doing a rough sketch of the parabola, we have the critical values 3 and negative 6. And drawing a happy face parabola, we focus on the parabola being less than 0, which is underwater. And so the domain is between these two numbers. We have x is between 3 and negative 6. But there's also one more subtle, hidden domain. We're talking about the width of a rectangle, so x must be greater than 0. So putting this together, we replace the lowest restriction negative 6 with 0. Thus x is between 0 and 3. By the way, when x is 0, the lower bound value, the y value is 3 larger. So the lowest possible value for y is 3. And the largest value for x is 3. And the y value is 3 larger than that, which is 6. So the possible dimension in the box, x is between 0 and 3, whereas y is between 3 and 6. You need to make a rectangular garden which has an area greater than or equals to 8 kilometers squared. Given the length of one side is 2 kilometers shorter than the other, what are the possible values of the shorter side? Because we want to find the shorter side possible values, let's call that x. It's easier to define x as what we're trying to look for. So given that the shorter side is x, we know the other side is off by 2. One side is 2 kilometers shorter than the other, so because we know this is a shorter side by 2, we'll call this x plus 2. The shorter side is x, and the longer side is x plus 2. This side here is 2 shorter than x plus 2. We know the area formula is base times height, so we have x times x plus 2 is the area. And the goal is for the area to be greater than or equals to 8. So the area is greater than or equals to 8. We now use algebra involving an inequality statement. We use distribution. X times x is x squared. X times 2 is 2x. And we throw the 8 over, we have minus 8 is greater than or equals to 0. We now factor. The quadratic factors to x plus 4, x minus 2. And so we have the critical values at negative 4 and 2. We have a parabola, and we're interested in when the parabola is greater than or equal to 0, above the x-axis. So the domain of x is less than or equals to negative 4, the lowest number, or x is greater than or equals to 2, the largest number. However, recall that x is the shorter side, and we know that when dealing with a rectangle, x must be greater than or equal to 0. The fact that x is greater than or equal to 0 or positive, we immediately reject this possible domain restriction. But putting these two together, x is also greater or equal to 2, this overrides this restriction here. Thus, x is greater than or equals to 2. In this question, we were asked when this quadratic x plus 2 was greater than or equals to 8. This green line is y equals 8. And it is true when x is greater than 2, as we can see by this blue line. We define x as the shorter side, which is exactly what we're trying to solve. What are the possible values of the shorter side? And the answer is x is greater than or equals to 2.